Hello my dear students, in this lecture we are going to see few theoretical questions which were asked in previous year GATE examination on the topic of transient heat conduction. The very first question which was asked in GATE 2014 for 1 mark in set 1 is the Biot number signifies the ratio of. Now my dear students, many students might be knowing this answer, but here in this lecture we will learn this Biot number because the next 3 to 4 questions are exactly similar. That is, what is the Biot number? In Biot number, different things they are asking, right? So let us understand this Biot number. Now my dear students, this Biot number is represented by Bi, right? Let us say you have one solid object. Let us say this is a solid object. This is a solid object, and this solid object is at initial temperature Ti. This Ti is a solid object temperature, right? And let us say this solid object is surrounded with fluid, right? This solid object is surrounded with fluid of convective heat transfer coefficient H and temperature T infinity, right? Now this solid object will be having thermal conductivity K. K is the thermal conductivity of solid, right? And let us assume the initial temperature of solid object is more than surrounding fluid temperature. Therefore, my dear students, because of this temperature difference, can I say this solid object will continuously lose heat to the surrounding by convection? Therefore, the solid object will continuously lose heat to the surrounding by convection, and slowly the temperature of solid object goes on decreasing, right? Now my dear students, this Biot number is defined as it is HL divided by K of solid, right? It is for solid object. Thermal conductivity is for solid object. You might have learned about Nusselt number, which is used in convection, right? This Nusselt number is nothing but HL divided by K of fluid, and it is used in convection, right? That is in fluids. But Biot number is HL divided by K of solid. This is very important, right? So my dear students, now here Biot number is HL divided by K of solid, where H is convective heat transfer coefficient between solid body and the surrounding fluid. L is a characteristic dimension. Here this L is characteristic dimension, which is nothing but volume of the body divided by surface area of the body in contact with the surrounding fluids. Right, volume divided by surface area. This is characteristic dimension, and K is the thermal conductivity of this solid body. Right. So my dear students, can I write this Biot number as? Let us write this. Now HL divided by K of solid, right? Now if I multiply this with area and divide with area, then it is absolutely fine. Again, can I write it is as L divided by Ka, L divided by Ka, this term, this L, this K, and denominator A. And this HA, I will take to the denominator of this, right? Therefore, it will become 1 upon HA, 1 upon HA, right? And my dear students, L divided by Ka, K is the thermal conductivity of solid. Therefore, this L divided by Ka in a conduction topic, in plane slab topic, we have seen this is a conduction resistance of solid. Therefore, we can say this L divided by K is conduction resistance, R conduction of solid, right? It is the R conduction of solid divided by. Again, in convection topic, we have seen 1 upon HA is convection resistance. Therefore, it is R convection. R convection. Therefore, my dear students, the definition of Biot number is it is a conduction resistance of solid divided by convection resistance of surrounding fluid. So, the same Biot number we can define as, now let us understand, the same Biot number we can define as, this Biot number is nothing but, now here, it is a conduction resistance of solid, means we can say it is an internal conduction resistance of this solid, right? It is a internal conduction resistance of solid divided by, it is a convection resistance, and convection resistance is external to the solid. Therefore, we can define external convection resistance. Therefore, my dear students, the Biot number is defined as internal conduction resistance of solid divided by external convection resistance. This is the basic definition of Biot number. Now here, whenever this Biot number value is less than 0.1, then the problem is called lumped heat capacity analysis. Then the problem is called lumped capacity analysis or lumped analysis problem. Lumped capacity heat analysis or lumped analysis problem. And my dear students, whenever Biot number is very less, that is 0.1, that means we can say the internal conduction resistance is very less as compared to external convection resistance, right? Therefore, simply we can say whenever it is a lumped analysis, then Biot number is very less, then internal conduction resistance is very less as compared to external convection resistance. Therefore, simply we can ignore this internal conduction resistance. This internal conduction resistance is almost negligible, almost negligible. Therefore, my dear students, the definition of lumped analysis is nothing but the Biot number is very less than 0.1, and the internal conduction resistance is negligible, then it is called lumped analysis. Now, on these all concepts, they can ask you any question, right? Now, let us understand here one by one. Now, very first question is the Biot number signifies the ratio of, it is the conduction resistance of solid divided by convection resistance. So, conduction resistance in solid to the convection resistance in fluid. Convection resistance is always in fluid. Therefore, for this question, option B will be the correct choice. Now, let us look at the second question. Now, the second question, which was asked in GATE 2011 for 2 marks, is based on Biot number again. So, let us understand the question. The question is a spherical steel ball. Now, my dear students, they have given spherical steel ball, right, of 12 mm diameter. So, here I can say, let us draw the sphere. Let us say this is a ball which is spherical, right, having diameter 12 mm. Therefore, can I say diameter is equal to 12 into 10 to the power minus 3 meter, right? Now, is initially at 1000 Kelvin. Now, initial temperature of this ball, Ti, is nothing but 1000 Kelvin. Then, it is slowly cooled in a surrounding of 300 Kelvin. Now, surrounding temperature, which is T infinity, is given 300 Kelvin, right? Then, the heat transfer coefficient between the steel ball and the surrounding is 5 watt per meter square Kelvin. Now, it is heat transfer coefficient means H between the ball and surrounding is H, which is 5 watt per meter square Kelvin, right? Then the thermal conductivity of steel is 20 watt per meter Kelvin. Therefore, it is K value. K is 20 watt per meter Kelvin. After that, the temperature difference between the center and the surface of the steel ball is. Now, for this steel ball, we have to find this temperature difference between center and the surface. This temperature difference we have to find. Now, let us understand here. First of all, let us check the Biot number. Now, my dear students, Biot number is nothing but Biot number is HL divided by K, right? Where L is volume divided by surface area. Therefore, this L can be calculated as volume divided by surface area. Volume of sphere is 4 by 3 pi r cube. Surface area is 4 pi r square. Therefore, here 4 pi and r square will get cancelled. It will remain r by 3. This characteristic dimension will remain r by 3, which is nothing but d by 6, right? So, my dear students, let us put this L as d by 6 over here. Then this Biot number will become H d by 6 into K. So, let us put the values. H is given 5, diameter is 12 into 10 to the power minus 3, divided by 6 into thermal conductivity is given 20. If I find this Biot number, I will get Biot number is equal to 5 into 10 to the power minus 4, which is very, very less. And again, we can say it is less than 0.1. Therefore, my dear students, for this question, the lumped heat analysis is valid, right? For this question, the lumped heat analysis is valid. And as Biot number is very, very less, the definition of Biot number just now we have seen, the Biot number is nothing but, this Biot number is nothing but internal conduction resistance of solid divided by external convection resistance. Therefore, as Biot number is very less, we can say this internal conduction resistance offered by solid is very, very less as compared to external convection resistance. Now, as there is no resistance internally, therefore the heat transfer will be maximum, thereby normalizing the temperature of body same at each and every location. Whenever internal conduction resistance is very, very small, then the at each and every location, the temperature of body will be same. Because the resistance is very small, therefore heat transfer is very high. Heat transfer will be very high, therefore normalizing the temperature at each and every location. Therefore, at each and every location, the temperature will be same. Therefore, change in temperature within body will be approximately equal to 0. Right. Therefore, the temperature difference between center and surface will be very small. Right. Now, let us understand. Here they are asking the temperature difference between the center and the surface of the steel ball is small because conduction resistance is far higher. Sorry, this is not the correct. Conduction, they are saying conduction resistance is far higher. No, conduction resistance is far lesser. Now here, small because conduction resistance is far less than the convection resistance. Yes, exactly. Option D will be the correct choice. Now again, next question which was asked in GATE 2002 for 1 mark is, the value of Biot number is very small, less than 0.01. Now whenever Biot number is very small, then internal conduction resistance of solid is very small. Therefore here, look at the option, the convection resistance of fluid is negligible. No. The conduction resistance is negligible. The conduction resistance of fluid is negligible. No, again. It is, they are mentioning for fluid, but it is for solid, right? Then the conduction resistance of solid is negligible. Yes, exactly. Option C is correct. Whenever Biot number is very small, then conduction resistance of solid is negligible. Now the next question from GATE 2001 for 1 mark is, the lumped heat transfer analysis of a solid object suddenly exposed to the fluid medium at a different temperature is valid when? Now they are saying the lumped heat analysis is valid when the Biot number is less than 0.1. Just now we have seen. Therefore option A will be the correct choice. Again very simple from GATE 1991 for 1 mark. Biot number signifies. We have seen the Biot number. Biot number is nothing but internal conduction resistance of solid divided by external convection resistance of fluid. Right. So let us check the option. The ratio of internal conduction resistance to the external convection resistance. Therefore for this question option D will be the correct choice. Again the next question from GATE 1989 for 1 mark. Again very simple question. Again repeating on the Biot number only. The heat transfer process between a body and its ambient is governed by an internal conductive resistance ICR and external convective resistance ECR. The body can be considered to be lumped heat capacity analysis is. Now the body can be considered as lumped heat capacity analysis whenever Biot number is less than 0.1 and the internal conduction resistance is negligible. Right? Don't say it is small or large. It is very small. This internal conduction resistance is very small as compared to external convection resistance. Therefore we can say internal conduction resistance is negligible. Right? Therefore here option D will be the correct choice. Thank you dear students. In next lecture we will see one more numerical on this topic which was asked in previous year GATE examination.